In this video, we're going to do a quick introduction to a key concept in thermochemistry called enthalpy of combustion, or heat of combustion, or standard enthalpy of combustion. It is, by definition, the enthalpy change when 1 mole of a substance is completely combusted in oxygen under standard conditions, which means at 298 Kelvin and 1 atmosphere of pressure. Because it's combustion, then it's going to always have a negative enthalpy change. So if you do work these out and you get positive, you need to know that you've either made a mistake or you need to change the sign. It'll often be with organic compounds, but not always. So the first example I'm going to work through is the combustion of methanol. So the first thing you do when you have to do anything with the enthalpy of combustion is you do a balanced equation for its complete combustion. So with organic compounds, so things with carbon in them, combusting it with oxygen is going to make carbon dioxide and water. Now I'm going to do another one shortly that's a different combustion, just to show you what's happening there. But with anything organic, so with carbons, you're going to have carbon dioxide and water. The first step is to do a fully balanced equation. So just like we did in year 11, year 12, we're going to balance this. But in the definition, it says that it's only 1 mole. So because it's 1 mole, we need to do something if the equation has more than 1 mole of that. This is where things get a little bit different for balancing equations to what you've seen probably before. Because there's 2 moles of methanol in my balanced equation, I need to divide this whole equation by 2, so that this ends up being a 1, as you can see here. So 3 divided by 2 is going to be 3 over 2, or 1.5. You can write it as 1.5. 2 divided by 2 is 1. 4 divided by 2 is 2. So this bottom equation is actually the correct equation for the enthalpy of combustion of methanol. Now the reason we can have 3 over 2 or 1.5 is because the numbers in front of these actually represent a number of moles. So if I had 1 mole of this, I would have 1.5 moles of this, making 1 mole of this and 2 moles of this. So I'm allowed to have halves and thirds and quarters and that sort of thing for this sort of thing. So the next one I'm going to look at and go through is the same as to give the equation for the enthalpy of combustion for magnesium. Now magnesium's not an organic compound, so we have to think about what would be made. So we should have met this one before. We would have magnesium, states of matter are important in this, plus oxygen at room temperature will make some magnesium oxide, which is a white solid. So we've got our equation, and then we're going to balance it. So just bear with me while I change pens. If I've got 2 oxygens here, I must have 2 magnesium oxides, and that would leave me with 2 magnesiums. I'm not allowed to do this because magnesium can only have 1. So I divide the whole thing by 2, and I end up with magnesium, again, like we had before, plus, now it's going to be a half oxygen, it's a half a mole of oxygen, going to magnesium oxide. And I know that that's balanced. And then that'll have a certain value that I can look up or I'm given in the question. So standard enthalpy of combustion is the complete combustion with oxygen of 1 mole of a substance under standard conditions, which is 25 degrees Celsius and 1 atmosphere of pressure. If our balanced equation has more than 1 mole, like you can see here, we have to then divide by the number in front of that to get our final equation. We're allowed to have halves and thirds and quarters because for other things, because they represent a mole ratio or a number of moles.